In this video, I'm going to focus on centripetal net force equations, something I like to call FC equations. These are a central part of the 2D dynamics unit, or the uniform circular motion topic. So what are FC equations? These are to circular motion what net force equations are to linear motion. Net force, this is the vector sum of forces used when an object has a linear or tangential acceleration. So you are analyzing the linear motion of an object, and you are using an F-net equation to explain why it is speeding up or slowing down. Fc is the vector sum of forces used when an object has a centripetal acceleration. This means the object is turning, likely moving in a circular path, and we'll want to write an Fc equation to explain which forces are responsible for the object being able to turn. So said simply, if you're dealing with straight line forward-backward motion, think about F-net. If you're dealing with a turning or circular motion, think about Fc. Conceptually, we need to understand that the net centripetal force will always point towards the center of the circle. We need more inward force than outward force in order to turn in a circular path. Here are 4 steps to properly complete an Fc equation. Number 1, we need to identify the proper forces. Draw a good force or free body diagram for the object, considering your usual forces, gravitational, normal, tension. Any force might appear in your eventual Fc equation. From there, we want to determine which forces are in line with the center of the circle. So find the center of the object's circular path, and look at your force diagram to pick out any forces that are pointing in towards center or also away from center. These forces will appear in your Fc equation. In order to make the net centripetal force point inward, the inward forces are automatically greater in magnitude than the outward forces. So from there, we're going to write our Fc equation as the larger forces minus the smaller forces, meaning the inward directed ones minus the outward directed ones. If you can follow these 4 steps, it should lead you to the proper equation. Let's look at an example. Here we have a satellite moving with a uniform circular motion around Earth. We're going to try to complete a force diagram for the satellite and use it to write an Fc equation. Step 1, we want to identify the forces. I can think of a single force acting on the satellite. There is a force of gravity on the satellite provided by Earth and pointing right at the center of Earth. Step 2, let's determine which forces are in line with the center of the circle. The center of this satellite's circular path is the center of Earth. I'm putting in this dotted reference line that connects the satellite to that point. You don't have to draw this line. It's just a visual to show you that the force of gravity is on a line connected to center and will appear in my Fc equation. This force is why the satellite is able to turn. If there were any forces up here away from center, they would appear in my equation too. I just don't have any for this particular scenario. Step 3, we want to understand that the inward forces are automatically greater than the outward forces, and this puts the net centripetal force directed inward. So here we have one inward force, gravitational force, and no outward forces. We can make a statement that Fg is larger than 0, but if there were any forces away from center, gravitational force would have been larger than those. At this point, many students make the same mistake. They get used to writing net force equations from their previous physics topics, and so they might try to write one here. Unintentionally, they would be saying that this satellite would be moving in a straight line, accelerating, and eventually crashing into Earth, which we know doesn't happen for this problem. This satellite is not moving in a straight line. It is moving around a circular path, so we don't want net force, we want centripetal net force. The final rule for writing an Fc equation is to take your forces and subtract them in minus out. Here we have Fg in and 0 out, so my centripetal force equation would be equal to the gravitational force, and now I can use this to sub in future equations and numbers specific to this scenario. We'll end with one last example problem. Here we have a ball rolling over the top of a frictionless curved ramp. So this isn't a full circle that the ball is traveling around, but while it is turning, that mimics a circular motion, and we will attack it with the same strategy. So the goal is the same. Can we complete a force diagram for the ball, and can we use it to write a centripetal net force equation? First step is to identify the forces acting on the ball. I can think of 2 of them. We have a downward gravitational force provided by Earth, and an upward normal force provided by the curved ramp. The center of the object's circular path is down here, below the ball, and so I'm drawing the force of gravity as a longer vector than the normal force, and I'm stating as much here. Remember, the inward forces towards center are automatically greater than the outward forces away from center. The last step is to write my centripetal net force equation as in minus out. Here I'll do gravitational force minus normal force, and this is the equation I'll need when numbers become important for the problem. If you want to practice what was covered in this video, check out the video description. I have linked my centripetal net force equations worksheet, a few more scenarios where you are trying to work through the steps necessary to write a centripetal net force equation. If you found this video helpful, then I have other resources that you may be interested in as well. For more information, check out my website, shoot me an email, or follow me on X and Facebook. All of the links can be found in the video description.